Hello everybody, my name is Mateusz Kubuszok, I'm from Scala, and I'm willing to talk about how to create high quality with Scala from the day one. I myself currently work as a Scala developer. My company is Scala Consultants based in Polish. We have clients from all over the world, from United States, Germany, and several other countries. My personal background is I've been a Scala developer for almost a year. Earlier I was also C++ programmer or Java programmer. In studies I was doing Java, C. Earlier on I was also doing some PHP. So very mixed background. Gives me some perspective on how different programming language works and what I like and what I don't like. So today I'm going to talk about several things when it comes to Scala. First, I'm going to talk about project setup, how we can get the most of our project setup SBT configurations so that our build tools can make a lot of automatic checking for us so that we don't have to struggle with a lot of errors that computer can check. Then I'm going to talk a bit about clean code because there's a lot of issues when it comes to Scala that I've seen both in the code bases that we were working with and with the interview program that we received. So some more typical errors needs to be discussed. And finally, I'm going to talk a little bit about the teamwork. How could we design our codes that it will be more friendly to our users and to our colleagues. So first, setting up project. Why I think is very important. Usually we start with a little project like that. We just put a name, versioning, some dependencies. And then on we learn that this setup is not always optimal. When it comes to models, we can get a lot of them. For instance, when we have people who work with layered architecture or hexagonal architecture of someone who is working with DDD, which is a big name these years, they might discover that keeping everything in one single module is a big struggle. If we instead separate things into different modules, we can force compiler to check several things for us, because when we define things in terms of separate modules, all of the dependencies between components in those modules are one way. So we can prevent some breach of abstraction happening on the compile level. For instance, if we extract the interface layer and module layer and application layer with business logic, we can make sure that compilers check for us that inside the module we don't use anything that should be in the business logic. In the infrastructure layer we don't use any components that should belong to the module, and so on. Similarly, with hexagonal architecture or with the boundary context, we can clearly separate responsibilities between the modules, and then compiler will do some checking for us. So how could we achieve that with SBT? Well, with SBT, simple modules should be achieved simply. So that's one example how we could split our project into several smaller sub-projects. But that's not everything we can achieve. We can also use some Scala to extract most common setups, put them into traits, and then we can refer those traits inside our SBT build, so that we won't repeat ourselves. So basically applying dry principle to our build tool. But what else we could achieve with SBT? Basically, splitting project into models and compiling is what any other build tool can do. But we can also do some, well, unit testing. It's also something everyone does everywhere. SPETS2 tools is one of the examples of unit testing framework that we can use in Scala. Basically, when we work with program, sooner or later we're going to learn that without any tests our code is going to break, because anytime someone can get in, do some small modification, and then our code breaks. Without any kind of regression test, we're going to learn the hard way. Running it from SBT is also very simple. We can address all of the tests in the project or just select some of the modules if we use multi-module architecture and then run it. But we can also check the test coverage, which is also very interesting. Many times we have the situation where we're using tests, but some developers didn't pay attention to it, they didn't want to introduce anything to our code base, and at some point we have a lot of modules that were completely untested. So any time someone went in and introduced some change, those modules could break, and no one would knew about it unless it was already too late. So code coverage gives us some information about where we could point our attention, where we should look more deeper and maybe investigate what could possibly go wrong. It's quite easy to use some code coverage metric with SBT. We need just to add a plugin, in this case SBT S-Coverage plugin, and we just apply the settings and we're good to go. We simply run clean, coverage, and test. That clean and coverage is a requirement of a plugin. In case we don't run the coverage testing on a clean project, our plugin might not notice all the changes. It might only perform code coverage on the recent changes, which is not what we want. It's a bug in the project, and we'd have to live with it. Coverage aggregate, on the other hand, is something that we have to use in multi-module projects so that this test coverages of all the small modules could be aggregated and gave us the information about what is the coverage of a whole project. Some other interesting tools that we can also apply with SBT are Scala reform. It's automatic formatter, which is run in compilation, so that each time we compile our code, it will be formatted according to some earlier defined rules. It's very important because very often people spend a lot of time arguing about some small issues like code formatting, indentation, spaces versus tabs, whether or not some variable should begin with a big capital or without capital. In the long run, it's not that important, but to avoid such needless discussions, we can simply enforce the rule on everyone. Just make the team agree on some rules and then make the automatic tool get it done for us. Other plugin is the Scala stage check, which doesn't necessarily introduce any changes to our code, but instead it can check the code and compare it to some guidelines. For instance, if our code compliant to characters limits per line, if our code doesn't contain anything like println. So it's also very useful to get rid of some code not compliant to some guidelines we agreed on. So it's also very simple to set up. Once we added the plugins, we just simply apply the settings to our build and simply run SBT. As I said, Scala reform will format whole project on each compilation, while Scala style will check everything on SBT Scala style. it uses Scala style config XML for it. It's quite a large file which allows us to configure a lot of checks when it comes to style guidelines. It could be automatically generated by task SBT Scala style generate config. So it's also quite simple to start using it. When it comes to Scala code itself, there are several ways in which the code is usually written in a not really good way. When we look at the projects that are sent during our interview questions, we usually see that a lot of people still use Java like Scala. Java-like code inside Scala. One of the examples of it is using return. Basically, Scala is a functional programming language. So each time we write some code, the last statement in our code is the value of the whole expression, the whole block of statements. So the usage of return is usually redundant. It's also not really good when it comes to declarative style of programming. It gives you bad flow. So usually each time you see return in your code, when you look closer, you'll see that you can replace whole code with something much simpler. In this case, we can replace that whole manual searching and checking with simply applying some predicate the function exists with, which checks if there is some element in our collection which fulfills the predicate. Similarly, return when it comes to searching first element which fulfills the predicate can be replaced with find function. There's a lot of other examples like that with manually going through the code. Yes?
Sorry, just a quick question then. I know people do call it a functional programming language, but can you really claim that if it lets you write code like that? I mean, you can say it supports functional programming, but I don't think it's very accurate to call it a functional programming language.
I would say that it's multi-paradigm language with very heavy which very heavily supports functional programming and encourages. We use immutable collections by default. You have to explicitly state that you want to use something mutable. You also...
it's hybrid.
It's hybrid. You can write in it like in Java, but it's
not
highly...
encouraging it here, is it? It's not encouraging...
I'll actually show this example as something that I very often see in the code from our interviewees, but which is why we turn them down, because they write imperative code or imperative-like code within language that is that really wants you to go toward functional style. It's more of legacy stuff, something to make you compliant to the Java, so that you could use Java libraries or make new Scala programs slowly gets into the language. But as you get more and more into the Scala practices, the principles, you'll see that it's highly discouraged to write the code this way. At least in the companies that value their time and value their money. Another example is something like that, when people start using vars. You can use variables inside Scala, but it's highly discouraged to the point that more than one tool reports using var as a warning. So, for instance, Scala check by default reports var as a warning. You are warned that you used variable. You perhaps wanted to use something else that you could avoid it. In this case, aggregation could be replaced by fold or reduce or sum, because these are numbers. Similarly, when it comes to multiplication, you also can use some fold function, reduction, product, whatever is your case. Those are some common problems when it comes to people that are new to Scala and comes from Java background or have some experience similar to Java. But it's not encouraged. It's something that community and more senior developers discourage and learn and teach their coworkers about how to avoid it, how to replace it with something better. Even Odersky, in his course on Scala on Coursera, he named his course Functional Programming Principles with Scala. So the language designer itself is very heavily biased toward functional programming, and all of this imperative stuff is just something that was added here for the sake of backward compatibility with Java. It's not something that any seasoned Scala developer would use if he didn't have to. Another thing that is also, well, it's kind of a controversial topic, because a lot of Scala developers use exceptions, even though the deeper you get into the language and the libraries that arose around the core Scala, the more people are trying to convince you not to use exceptions, that exceptions is something evil that we should get rid of. Here you have two example functions where some Java developer would use exceptions to avoid errors, and then wrap it with try-catch. The first one simply will return empty sequence if there is some no number in a sequence separated by commas. And the other one will use optional type. If everything could be parsed, then we get the sequence. If at least one element can be parsed, then we get none instead of error. But there are some better ways. One of the ways to improve it is using try. Try is, well, Odersky himself proved that it's not a monad. It doesn't follow, I think it was right unit law. Anyway, it's not monad, but it's still very useful. Any expression statement that we put into try will be evaluated, error will be catched, and the result is a abstract algebraic data type of success, failure. Success contains result, failure contains exceptions, so that each time we handle some strictly Java code which might throw exceptions, we can wrap it with try and then handle it in a functional way. Here are some examples how we could do it. But still, if you get even deeper into Scala, you'll see that it's not the most encouraged approach. More encouraged approaches are based on Ether, which is an algebraic data type of left and right, similar to the one in Haskell. There are also some extension of the Ether, because Ether in Scala is not biased towards left or right values, so you cannot put it into for comprehension, you cannot use it like a monad. But there are some supplemented counterparts in Scala's library, like validation or V, which is type using / and \. They're designed specifically toward handling errors, so you can use them similarly to Ether monad in Haskell. So just simple reminder that you shouldn't iterate manually, because it's imperative style. There are a lot of functions like fold, reduce, exist, for all, find, partition, and so on, so that you can handle it in a functional way, that you shouldn't throw exceptions, because it's a very Java-like programming, and there are better way to do it, more functional one. those are just some examples. In general, try not to write mutable code with mutability, code with mutable state, imperative one, because Scala encourages you to write code in a functional way, because it's more safe and easier to grasp. The two previous presentations shown you why functional is better than imperative, so I won't repeat. Okay, so when it comes to using Scala features, from my and my colleagues' experience, just try to avoid cake pattern because it almost always fails. Try to avoid tuples in public API because they are difficult to comprehend, and case classes are better alternative. And extremely long mono chains for using for comprehension or plain map, flat map filter also difficult to grasp for your average developer. So this is also something that you should think about it. And also using pattern matching to distinct types when something that could be checked on compile time and you don't intend to handle everything but just some subset of it. I also want to say a few words about keeping other people in mind. Usually when we write code, we want to communicate with other people. So we want to do it in a way that will be the most effective. Deciding on conventions would be one thing to do it, because when we have some convention in code, we can easily find class or module that we are looking for. Using the script meaningful names, it's something that is pointed out in every book, but very often when I look at the code, I see that people are not good at naming things. They don't even try it. For instance, recently I saw code when someone was handling some very specific collections of models, and he decided to use X and XS names in the whole of all the code base. So it wasn't telling me anything about what he handled. If not for the long comments in front of the function, I wouldn't be able to tell if he was doing it right or wrong, or if he was on what he was doing at all. Also, you should using types to inform your users so that what you intend from him, for instance, string and long, is usually when you use it to pass numbers and some sort of text. But when you want to get some more specific information, for instance, it's user or user ID, you can wrap it into some small case class which will simply inform your API users what you are doing. Commenting concept that can be expressed with code. It's obvious that we should avoid commenting code because each time we pass the information to our user by comments is kind of a failure, but some concept cannot be expressed by code, like why we decided on this kind of architecture, if we made some modifications due to inefficiencies. These things usually can be expressed with the good naming or functions or modules, so we have to resort to using comments. I also forgot to write it here, but there's also a thing of code partitioning. Very often when it comes to Scala, you have a problem that you have two groups of programmers with different backgrounds. For instance, one of people who have a lot of experience with OCaml or with Haskell. They are very good at functional programming and grasp very high-level concepts easily. And the rest of your team is composed of people that just came from Java. And at this point, if you try to force too much on your colleagues, they might not handle it. When you try to be using some free monads and some higher order not higher order functions, something like arrows and too much of a custom type classes, they might easily get lost, and you end up with partitioned team where several people from your team are able to handle all of the code base, and the rest of them can only handle the pieces that don't use too much of more advanced concepts of functional programming. So to handle this kind of situation, you would consider how to introduce some concepts to the new people and do it gradually, so that they would grow with the projects, so that the project wouldn't overburden them. Well, the last thing I have to say is also you have to think about your users, your contributors, so you should focus how you express new code so that you can easily understand without a ton of documentation. But documentation is also good. You should provide README. A lot of people have quite good projects, but they forgot to add README to their GitHub pages, so you cannot even. You have to dive into the code to understand what they're doing, what they're trying to achieve, and how you can use it. Simple thing, but many people forget about it. Documenting things that could be important to user, so that he can find easily. One of the projects I recently made use of was about providing Android SDK to the Scala, but since the developer completely forgot about the documentation, you have to spend a lot of time digging up on the GitHub issues and Stack Overflow, because he didn't provide enough documentations to make you able to use his project the way you wanted. And the last thing is about being responsible, which is something we all here do, obviously. So this is a little summary. Use the possibilities that the build tool gives you, so that you can establish some sort of safety nets, which will save you from the errors that mistakes we usually make during programming. Try to avoid Java in Scala, because Java is imperative and bad, and Scala tries to be functional and pure and good. And less is more. Try to think about how to express yourself in the most clean way, so that the users can use your code easily and developers can contribute without headache. Just think about the people that would try to use your project and contribute to it. Okay. So, any question?